Welcome, dear listener, to Sleeping Researcher, your gentle guide through the wonders of science, designed to ease your mind and help you drift into peaceful sleep. Here we explore fascinating ideas in a calm and soothing narration, inviting you to relax, unwind, and discover the mysteries of our universe without rush or distraction. Tonight, we embark on a journey beyond the familiar, a journey into the captivating realm of multiverse theories, parallel universes, and alternate dimensions. These concepts stretch the boundaries of our imagination and challenge what we think we know about reality itself. What if our universe is just one of many? What if countless versions of ourselves exist, living out different choices and possibilities? And what might it mean to explore dimensions beyond our three-dimensional experience? As we slowly navigate these intriguing ideas, allow your mind to float gently through the vastness of space and time, embracing the calm curiosity that comes from pondering the unknown. If you find comfort and wonder in this narration, please consider liking the video and subscribing to Sleeping Researcher. Your support helps us continue bringing you peaceful explorations of science, perfect for bedtime or quiet moments. Now, let us begin our serene voyage into the multiverse, where infinite realities await, and the fabric of existence whispers its secrets in the quiet. Imagine for a moment that the universe we inhabit, vast as it may seem, is but a single bubble in a much grander cosmic ocean. This idea, both humbling and exhilarating, forms the foundation of what scientists and philosophers call the multiverse. Instead of one solitary universe, the multiverse concept suggests there could be countless universes, each with its own set of physical laws, constants, and perhaps even dimensions. This notion stretches the boundaries of our understanding and invites us to ponder realities far beyond our own, igniting a deep curiosity about the true nature of existence. As we begin this exploration, it is important to remember that the multiverse remains a theoretical framework, a profound hypothesis born from the edges of modern physics and cosmology, rather than a proven fact. At the heart of multiverse theories lies the idea of parallel universes, separate, self-contained realities that exist alongside ours. These parallel worlds might be strikingly similar to our own universe, or wildly different, governed by alternate outcomes or physical laws. The concept finds roots in quantum mechanics, where particles can exist in multiple states simultaneously, hinting at the possibility that every decision, every random event might spawn a new, branching universe. This perspective challenges our conventional understanding of time and causality, suggesting a vast, intricate web of realities unfolding in tandem. The beauty of this idea is that it expands the horizon of what is conceivable, encouraging us to think beyond the confines of our observable universe. Beyond parallel universes, some multiverse theories propose the existence of alternate dimensions, layers of reality that coexist with our own, but are imperceptible to us under ordinary circumstances. These extra dimensions could be compact, and microscopic, curled up so tightly that we cannot detect them directly. Or they might be vast and unfathomable, extending in directions beyond our three-dimensional experience. The exploration of dimensions beyond the familiar three spatial and one temporal dimension is a central theme in string theory and other advanced physics models, which seek to unify the fundamental forces of nature. The notion of alternate dimensions invites us to reconsider the very fabric of reality, hinting at hidden realms that might hold answers to some of science's deepest mysteries. The multiverse concept, with its parallel universes and alternate dimensions, also raises profound philosophical questions about identity, free will, and the meaning of existence. If countless versions of ourselves exist across different universes, each living out different choices and possibilities, what does that say about individuality? How do we understand our place in a reality that might be just one thread in an infinite cosmic tapestry? Such reflections extend the reach of scientific inquiry into the realm of metaphysics, reminding us that the quest to comprehend the multiverse is as much about understanding ourselves as it is about understanding the cosmos. As we continue, we will delve deeper into the scientific theories and evidence that support these fascinating ideas. To begin exploring the vast and intricate ideas behind multiverse theories, it is essential to first understand what we mean by the term universe. At its most fundamental, the universe can be described as the totality of all space, time, matter, and energy that exists. It encompasses everything we can observe, measure, and experience, from the smallest subatomic particles to the largest galaxies, from the birth of stars to the expansion of cosmic structures billions of light years away. This concept is not simply about the physical objects themselves, but also the very fabric of space and time that connects them. By defining the universe in this way, we establish a foundation upon which more complex ideas about multiple universes or dimensions can be considered. The universe is, therefore, the all-encompassing reality in which all known physical phenomena occur, setting the stage for scientific inquiry into its origins, structure, and ultimate fate. When we speak of the universe, it is helpful to remember that our understanding is shaped by observations and theories developed over centuries. The universe we perceive is governed by physical laws, such as gravity, electromagnetism, and quantum mechanics, that describe how matter and energy interact across space and time. These laws provide a framework for explaining everything from why planets orbit stars to how light travels through the vacuum of space. However, the notion of a single, isolated universe is increasingly challenged by theoretical physics, which suggests that the cosmos may be more complex than it appears. In this broader context, the term universe might refer not only to what we can see and measure, but also to a grander reality that includes realms beyond our current capacity to detect, inviting us to think beyond familiar boundaries. The idea that our universe might be one among many arises naturally when considering models of cosmology and quantum physics, For instance, some interpretations of quantum mechanics propose that every possible outcome of a quantum event actually occurs, but in separate, branching realities. Similarly, certain cosmological models suggest that regions of space-time can undergo independent expansions, creating bubble universes that may be disconnected from our own. In these scenarios, each universe would have its own distinct properties, physical laws, and histories, making the concept of a singular universe insufficient to fully describe the totality of existence. This perspective invites us to imagine a multiverse, a collection of many universes, each potentially as vast and intricate as our own. Understanding what a universe is also requires considering dimensions beyond the familiar three dimensions of space and one of time. Some theoretical frameworks, such as string theory, propose that additional spatial dimensions exist but are hidden from direct observation because they are compactified or exist at scales far smaller than atoms. These extra dimensions might provide the scaffolding for multiple universes where different physical constants or laws emerge, giving rise to alternate dimensions alongside our own. The interplay of these dimensions could be the key to uniting the laws of physics into a comprehensive theory, while also expanding the meaning of universe to encompass realms far beyond our everyday experience. Such ideas challenge us to broaden our imagination and scientific perspectives as we venture deeper into the mysteries of reality. The concept of the multiverse, or multiple universes existing simultaneously, did not emerge overnight. It grew gradually from the fertile grounds of theoretical physics and cosmology as scientists sought to understand the fundamental nature of reality. Early in the 20th century, the discovery of quantum mechanics and the strange behavior of particles at microscopic scales opened new doors to possibilities once thought purely philosophical. Physicists began to question whether the universe we observe is the only one, or if it might be just one instance among countless others, each with its own unique properties. This shift was further propelled by the development of inflationary cosmology in the 1980s, which proposed that the universe underwent a rapid expansion shortly after the Big Bang. This inflationary period could have produced bubble universes, each forming its own pocket of space-time, potentially with different physical laws. Such theoretical advances laid the foundation for what we now think of as the multiverse, inviting us to imagine a cosmos far more vast and diverse than previously conceived. Parallel to these cosmological developments, the interpretation of quantum mechanics added a profound layer to multiverse thinking. The many worlds interpretation, introduced by physicist Hugh Everett in the 1950s, suggested that every quantum event spawns a branching of reality into multiple outcomes, each realized in its own separate universe. In this view, all possible histories and futures exist in a vast, branching tree of parallel universes where every conceivable variation of events plays out. This idea challenged the classical notion of a single linear timeline and expanded our understanding of reality to include an infinite tapestry of worlds. While difficult to test experimentally, the many worlds interpretation provides a fascinating framework for considering how alternate dimensions might coexist alongside our own, each representing a different path taken or a different set of physical parameters. These ideas, though abstract, have captured the imagination of scientists and the public alike, inspiring new ways to think about existence and reality itself. Meanwhile, advances in string theory and higher dimensional physics have contributed another perspective on the multiverse, often referred to as the brain multiverse. According to this framework, our familiar universe might be a three-dimensional brain embedded within a higher dimensional space. Other brains could exist parallel to ours, each hosting its own universe with distinct physical laws and constants. The interactions between these brains could potentially explain phenomena such as gravity leaking from one brain to another, or even cosmic events like the Big Bang being the result of brain collisions. This approach elegantly ties together the geometry of extra dimensions with the existence of multiple universes, offering a rich mathematical structure to explore. It challenges us to consider dimensions beyond direct perception and to appreciate the deep complexity that might underlie the cosmos. Such theories continue to evolve, pushing the boundaries of cosmology and theoretical physics toward a more expansive view of what reality may encompass. The birth of the multiverse idea intertwines with profound philosophical questions about the nature of existence and our place within this potentially infinite landscape of realities. If multiple universes exist, each with varying physical laws and initial conditions, then the uniqueness of our own universe becomes less certain. This perspective has implications for understanding fine-tuning in physics and the anthropic principle, which considers why our universe appears so finely calibrated for life. The multiverse framework suggests that life, consciousness, and the very fabric of reality might be local phenomena in a vast cosmic ensemble. This challenges traditional cosmology, which centers on a singular universe and invites a more inclusive and expansive scientific narrative. While direct empirical evidence remains elusive, the multiverse hypothesis stimulates rigorous debate and inspires new avenues of research, inviting us to explore with an open mind the vast possibilities that lie beyond our observable horizon. As these scientific theories evolved, they have not only reshaped our understanding of the cosmos, but also sparked the imagination beyond traditional cosmology. The multiverse has become a compelling theme, not only in physics, but also in philosophy, literature, and popular culture, symbolizing the endless possibilities that lie beyond the known. It encourages a humility in our quest for knowledge, reminding us that the universe we experience may be but one thread in a much grander cosmic tapestry. This ongoing dialogue between science and imagination pushes us to refine our tools for exploring reality and to embrace embrace the mysteries that remain. The journey into the multiverse continues to unfold, inviting curiosity and wonder as we seek to grasp the profound nature of existence across dimensions and beyond. To navigate the vast and intricate landscape of multiverse theories, scientists have proposed a classification system that organizes these ideas into 4 primary levels, each representing a different kind of cosmic possibility. This framework, often labeled from level 1 to level 4, offers a roadmap to understanding the scope and diversity of what the multiverse might entail. At the heart of this classification lies the idea that our universe may be just one among many, each varying in scale, physical laws, or dimensionality. The simplest form, level 1, envisions an infinite expanse of space where regions beyond our observable universe contain other domains with similar physical laws, but different initial conditions. As we ascend the levels, the concepts become more abstract and profound, challenging our very notions of reality and existence. Level 1 multiverses arise naturally from the cosmological principle and the idea of spatial infinity. In this view, the universe extends without bound, and far beyond the cosmic horizon, there exist regions where particles, galaxies, and even entire planets might be arranged differently. Because space is infinite, every possible arrangement of matter occurs somewhere, implying that duplicates of ourselves may exist in distant reaches. Importantly, these parallel universes share the same physical laws and constants as our own, differing only in their initial conditions. This concept, grounded in the standard cosmological model, suggests that the observable universe is just a small patch within a much grander and uniform cosmos. It invites us to reconsider the uniqueness of our cosmic environment, as the infinite expanse contains endless variations on the familiar theme of existence. Moving beyond level 1, level 2 multiverses introduce the possibility of universes with different physical constants and laws of nature. This idea emerges from the inflationary theory, which suggests that during the earliest moments after the Big Bang, space underwent rapid expansion in different regions, leading to bubble universes that might have varied properties. Each bubble could have its own unique set of physical parameters, such as different strengths of fundamental forces or particle masses, fundamentally altering the nature of matter and energy within it. This level introduces a richer diversity of realities, where the conditions for life, chemistry, and physics itself might be radically transformed. Level 2 multiverses challenge our understanding by implying that the laws we observe are just one realization among many possible frameworks, expanding the horizon of what is possible in the cosmic panorama. At level 3, we encounter the many worlds interpretation of quantum mechanics, a concept that suggests every quantum event branches into a multitude of outcomes, each existing in its own parallel universe. According to this interpretation, all possible quantum histories are realized, creating a vast ensemble of universes that coexist simultaneously but do not interact. These parallel worlds are not separated by space, but rather by different quantum states, representing alternate realities where every decision, every chance occurrence has played out differently. This level brings the strange and counterintuitive aspects of quantum theory into the multiverse framework, presenting a vision of reality that is profoundly interconnected, yet infinitely diverse. It compels us to rethink the nature of observation, probability, and existence itself. Finally, Level 4 represents the most abstract and ambitious multiverse concept, proposing that all mathematically possible universes exist as realities in their own right. This idea, sometimes called the ultimate ensemble, suggests that any universe, describable by a self-consistent set of mathematical laws, has physical existence. In this view, our universe is just one among a vast landscape of possible worlds, each with its own distinct mathematical structure and corresponding physical reality. Level 4 pushes the boundaries of cosmology and philosophy, inviting deep reflections on the nature of mathematics, existence, and consciousness. It challenges us to consider whether the universe we inhabit is simply one instantiation within an infinite space of all conceivable realities. As we explore these levels, the multiverse emerges not just as a scientific hypothesis, but as an expansive framework that deepens our understanding of the cosmos and our place within it. At the foundation of many multiverse theories lies the idea of an infinite cosmos, stretching endlessly beyond the boundaries of what we can observe. In this vast expanse, the universe does not have edges or limits, but continues forever in all directions. This concept, often referred to as Level 1 multiverse, suggests that space itself is infinite and uniform on the largest scales. Because the universe extends without end, every possible arrangement of matter and energy will eventually reoccur somewhere within this boundless realm. This means that distant regions of space, unimaginably far from our own, might mirror the structure of our observable universe with remarkable precision, even down to the repetition of entire galaxies, solar systems, and perhaps life forms that closely resemble ourselves. Such a perspective turns the abstract notion of a multiverse into a tangible, almost intimate idea, one where the cosmos is a vast, repeating fabric of familiar patterns spread across infinite distance. The implication of this infinite repetition is profound. As we consider the vastness of space and the number of particles it contains, it becomes increasingly plausible that somewhere out there, countless versions of Earth and its history unfold. These parallel universes are not separated by hidden dimensions or exotic physics, but simply by the vast stretches of space that lie between us. From this vantage point, parallel universes are not separate realities, but distant regions of the same infinite cosmos, where initial conditions and chance have aligned to create nearly identical outcomes. This idea, grounded in classical cosmology
and supported by the known uniformity of cosmic background radiation, bridges the gap between imagination and scientific plausibility. It invites us to rethink our sense of uniqueness and place in the universe, understanding that what we know might be one expression among infinite repetitions of reality.
Moreover, this notion of infinite space and repetition connects deeply with our understanding of probability and the laws governing matter. Given the finite number of ways particles can arrange themselves within a given volume, combined with the infinite expanse of the cosmos, every possible configuration must recur infinitely many times. This includes not only repeating physical structures, but also the complex arrangements that give rise to consciousness and experience. It opens the door to the idea that somewhere, a version of you may exist, living a life nearly identical to your own, separated only by the vast cosmic gulf. Such reflections encourage a serene acceptance of the universe's scale and complexity, emphasizing the interplay between infinity, chance, and the patterns that emerge from fundamental physical laws. This perspective gently shifts our understanding of parallel universes from abstract speculation to an inherent feature of the cosmos itself. While Level 1 multiverse theory envisions parallel universes as distant regions in infinite space, it also sets the stage for more intricate ideas involving alternate dimensions and realities. The concept of repetition within infinite space helps ground more abstract multiverse models by providing a concrete example of how our universe might be just one of many, differing subtly due to variations in initial conditions or random fluctuations. This framework encourages us to explore further levels of the multiverse, where the nature of reality becomes even more varied and complex. As we contemplate the infinite vastness and the repetitions it entails, we prepare ourselves to journey deeper into the fascinating landscape of parallel universes and alternate dimensions, where the cosmos reveals even richer possibilities beyond the familiar. Building upon the notion of infinite space containing parallel regions, Level 2 multiverse theories introduce a profound concept rooted in the physics of the early universe: cosmic inflation. This rapid expansion, occurring fractions of a second after the Big Bang, is believed to have stretched space exponentially, smoothing out irregularities and setting the stage for the formation of galaxies and cosmic structures as we observe them today. However, inflation may not have ended uniformly across the entire cosmos. Instead, certain regions could have ceased inflating, forming distinct bubble universes, while other regions continued to expand at an accelerated rate. Each bubble can be thought of as its own universe, complete and self-contained, possibly with physical laws and constants that differ from those in our own cosmic neighborhood. This branching process significantly expands the multiverse landscape, suggesting a cosmic tapestry woven from countless bubble universes, each with its own unique properties. The intriguing idea of bubble universes arises from the subtle interplay between quantum fluctuations and the dynamics of the inflationary field. Quantum mechanics tells us that at the tiniest scales, uncertainty reigns and random fluctuations can influence the energy landscape of the early universe. In certain regions, these fluctuations can cause inflation to end, creating stable pocket universes, while in others, inflation persists. The implications are profound because within each bubble universe, fundamental constants, such as the strength of gravity, the masses of particles, or the behavior of electromagnetic forces could vary. Such variations might render some universes inhospitable to life as we know it, while others might harbor entirely different forms of matter and energy. This diversity, born from the inflationary process, paints a picture of reality that is far richer and more varied than a single, isolated cosmos. It invites us to reconsider the uniqueness of our universe and the possibility that what we observe is just one expression among an unimaginably vast ensemble. The concept of bubble universes also offers intriguing insights into some of the deepest puzzles in physics. For example, why do the constants of nature appear finely tuned to allow for the existence of complex structures and life? Within the Level 2 multiverse framework, fine-tuning may simply be a result of selection bias. We observe our particular set of physical laws because only in such a universe could observers like us emerge. In other bubbles, where constants differ significantly, complexity may never arise. This line of reasoning, often associated with the anthropic principle, shifts the perspective from seeking a unique explanation to embracing a broader cosmic context where countless variations exist. Furthermore, the idea that these bubble universes are separated by expanding space and might never interact challenges our traditional notions of causality and observability. Yet, even if these other universes remain forever beyond our reach, their theoretical existence reshapes our understanding of what the cosmos truly encompasses. While the mathematics of inflation and quantum field theory provide a compelling framework for bubble universe formation, empirical verification remains a formidable challenge. The boundaries between bubbles are thought to be inaccessible, hidden beyond horizons that no signal can cross. Nonetheless, scientists continue to explore indirect clues, such as subtle imprints on the cosmic microwave background radiation, or gravitational wave signatures that might hint at collisions between bubble universes. These investigations stretch the limits of observational cosmology, pushing our instruments and imagination alike. The concept also inspires new models in string theory and high-energy physics, where the landscape of possible vacuum states corresponds to different bubble universes. This rich interplay between theory and observation fuels ongoing research as we try to glimpse the broader multiverse through the narrow window of our observable cosmos. As we contemplate the vast array of bubble universes birthed by cosmic inflation, we find ourselves moving toward even more intricate multiverse levels. These further levels speculate not only on separate universes with different constants, but on alternate dimensions that may fundamentally alter the nature of reality itself. Such ideas invite us to expand our conceptual horizons, imagining realms where the familiar fabric of space and time is woven in unexpected ways. With the inflationary bubble universe model as a foundation, we prepare to explore these deeper layers of the multiverse, where the interplay of physics, geometry, and possibility continues to unfold. At the heart of modern physics lies a profound mystery: the nature of quantum mechanics and the peculiar behavior of particles at the smallest scales. Here, the conventional notions of certainty give way to probabilities, and events unfold not in a single, definite way, but in a spectrum of potential outcomes. The many worlds interpretation proposed by physicist Hugh Everett in the 1950s invites us to consider a remarkable possibility: that every quantum event, instead of collapsing into a single outcome, actually branches off into multiple coexisting realities. In this view, the universe is not limited to one linear history, but continuously splits into countless parallel worlds, each representing a different outcome of every quantum decision. This framework elegantly removes the mystery of wave function collapse, replacing it with a vast, ever-growing tree of universes that collectively embody the full range of quantum possibilities. This idea of a branching multiverse is not merely a philosophical curiosity. It is deeply tied to the mathematical formalism of quantum mechanics itself. When particles exist in superposition, states where they hold multiple potential positions or energies simultaneously, the many worlds interpretation suggests that all these possibilities are realized, each in its own separate realm. Imagine a quantum coin toss that results in both heads and tails, but in different universes. These parallel worlds do not interact or interfere once they diverge, rendering them inaccessible from each other. Yet they exist side by side within an unimaginably vast multiverse. Such a conceptual leap challenges our classical intuitions about reality, but remains consistent with the equations governing the subatomic world. Through this lens, reality becomes a boundless forest of possibilities, each branch a universe where a different outcome has taken shape. The implications of the many worlds interpretation extend beyond theoretical physics into philosophical and existential realms. If every possible quantum event creates a new universe, then the sheer number of alternate realities becomes unimaginably large, potentially infinite. This leads to questions about identity, fate, and free will, as every decision or chance occurrence spawns a new world where alternative versions of ourselves live out different lives. In addition, it offers a perspective on the fundamental nature of reality that is more expansive and inclusive than classical views. While these alternate dimensions remain beyond direct observation, their existence is woven into the very fabric of quantum theory. The many worlds interpretation thus provides a bridge connecting the microscopic quantum realm with the grand scale of the multiverse, revealing a cosmos far richer and more complex than previously imagined. Exploring these parallel universes invites us to reconsider our place in the grand cosmic tapestry. The multiverse suggested by quantum mechanics is not a singular, isolated structure, but a dynamic, infinite ensemble of realities, each branching from the smallest quantum event. This challenges the notion of a singular, objective history and suggests that reality is a vast, interconnected web of possibilities. While the many worlds interpretation remains one of several competing ideas about quantum phenomena, its elegant resolution of certain paradoxes and its profound implications continue to captivate physicists and philosophers alike. As we delve deeper into this conceptual landscape, the boundaries between physics and metaphysics blur, inviting a richer understanding of existence itself. With this understanding of quantum branching as a gateway to infinite realities, we prepare to journey further into the nature of alternate dimensions. Beyond the quantum multiverse, theories in physics suggest the existence of dimensions beyond our familiar 3 of space and 1 of time. These extra dimensions, hidden or compactified, could offer new insights into the fundamental structure of reality, potentially reshaping our understanding of forces and particles. As we move forward, we open ourselves to the possibility that the multiverse is not only about many worlds, but also about many dimensions, each holding secrets waiting to be unveiled. Beyond the realms of quantum mechanics and extra dimensions lies an even more profound and daring concept known as the level 4 multiverse, or the ultimate ensemble. This theory proposes that every universe that can be described by mathematics truly exists in its own right. It suggests that the fabric of reality is not limited to the physical laws observed in our own cosmos, but embraces every logically consistent mathematical structure as a distinct universe. In this view, the multiverse is an unfathomably vast ensemble containing all possible variations of existence, each governed by its own unique set of rules and constants. Such an idea stretches the imagination far beyond familiar territory, inviting us to consider the profound implications of a reality where every conceivable world, no matter how strange or alien, has a place within the grand cosmic tapestry. The level 4 multiverse challenges the traditional boundaries between physics and mathematics, suggesting that the latter holds the key to unlocking the ultimate nature of existence. Here, mathematics is not merely a tool to describe the universe, but its very essence. Every mathematical structure, from the simplest to the most complex, manifests as a universe with its own distinct reality. This perspective eliminates the need for arbitrary physical constants or unexplained fine-tuning, as all possibilities are realized somewhere within the ensemble. It also raises intriguing questions about the nature of consciousness and identity, as beings might exist in countless variations across these diverse mathematical realms. The beauty of this idea lies in its elegance and inclusivity, as it embraces every logically possible reality without exception. While the Level 4 multiverse remains a deeply theoretical concept, it offers a radical framework for understanding the cosmos that transcends conventional scientific paradigms. It invites us to reconsider what it means for something to exist and challenges us to expand our perspective beyond the familiar contours of space and time. The implications ripple through philosophy, physics, and cosmology, touching on questions of existence, reality, and the limits of human knowledge. Contemplating such an ensemble encourages a sense of humility and wonder as we recognize our place within an infinite ocean of possible worlds. Each universe within this ultimate ensemble is a testament to the richness of mathematical imagination, waiting silently to be explored in thought and theory. As we reflect on the profound depth of the ultimate ensemble, we begin to see how it elegantly unifies various multiverse ideas under a single, sweeping vision. From the branching worlds of quantum mechanics to the hidden dimensions of string theory, all find a home within this vast mathematical landscape. This perspective not only broadens the scope of scientific inquiry, but also nurtures a profound sense of curiosity and openness to the mysteries that lie beyond our current understanding. With this foundation in mind, we prepare to delve deeper into the philosophical and scientific implications of these boundless realities, inviting a journey that expands both mind and spirit. When we speak of parallel universes, we refer to a fascinating concept that distinguishes itself within the broader multiverse framework. Unlike the expansive and sometimes abstract multiverse theories that encompass all possible mathematical structures or infinite cosmic landscapes, parallel universes suggest the existence of realities that are closely related to our own. These alternate realms are not wildly different cosmic tapestries, but rather adjacent variations of the world we inhabit. Realities where the fundamental laws of physics remain consistent, yet small differences create alternate histories, outcomes, or events. This subtlety is what makes parallel universes uniquely intriguing. They invite us to consider the profound question: what if a slightly different choice in the past led to a new present? The idea of parallel universes often finds its roots in the interpretation of quantum mechanics, specifically the many worlds interpretation proposed by Hugh Everett in the 1950s. According to this view, every quantum event, every moment where a particle's state could split into different possibilities, branches off into a separate universe. These universes exist simultaneously, but remain non-communicative, each containing a distinct history shaped by the outcomes of countless quantum choices. This branching structure suggests a vast but intimately connected family of worlds, where every conceivable variation of events unfolds in parallel. Here, the universe is not a singular, linear narrative, but a sprawling tree of realities, each as real as the one we experience. Beyond quantum mechanics, the notion of parallel universes also intersects with ideas about alternate dimensions. While sometimes these concepts are used interchangeably, alternate dimensions often imply additional spatial or temporal directions that coexist alongside our familiar three-dimensional space and one dimension of time. In contrast, parallel universes are typically understood as separate, self-contained realities that share the same dimensional structure as our own. This distinction helps clarify the landscape of multiverse theories. Parallel universes emphasize variations of reality within the same dimensional framework, whereas alternate dimensions suggest the existence of entirely different axes of reality beyond our sensory perception. Such subtle nuances deepen our appreciation for the rich complexity of the cosmos. The scientific exploration of parallel universes remains largely theoretical, resting on advanced mathematics and interpretations of quantum phenomena rather than direct observation. Yet, the implications of their existence ripple through both physics and philosophy, challenging our understanding of reality, identity, and causality. If every decision or random event births a new universe, then the notion of a singular, objective reality becomes less certain. This invites a more fluid view of existence, where countless versions of ourselves could be living out different possibilities, each shaped by the delicate interplay of chance and choice. Such reflections offer a gentle reminder of the breadth and mystery that science continues to embrace. As we continue to explore these ideas, it becomes clear that parallel universes stand as a unique thread within the vast tapestry of multiverse theories. They offer a vision of the cosmos that is at once intimate and expansive, a realm where the familiar and the unfamiliar coexist side by side, shaped by subtle shifts and the delicate branching of reality's infinite paths. This perspective encourages both scientific inquiry and philosophical reflection, inviting us to ponder what it means to exist in a universe that may be one among countless others, each unfolding with its own story and potential. With this understanding as our guide, we gently move forward to consider how these alternate realities intersect with our quest for knowledge and meaning. At the heart of scientific exploration into multiverse theories lies an intriguing array of observations and data that gently nudge us to consider realities beyond our own. One of the most compelling pieces of evidence comes from the study of the cosmic microwave background radiation, the faint afterglow of the Big Bang that permeates the universe. Within this ancient light, scientists have detected subtle anomalies, slight irregularities in temperature and distribution that seem to defy simple explanation. These patterns, while delicate and faint, have opened a door to hypotheses suggesting that our universe might be just one bubble in a vast cosmic foam, each bubble representing a different universe with its own unique properties. Such findings add a layer of scientific weight to the concept of multiverses, inviting us to reflect on the possibility that the fabric of reality is far richer and more intricate than previously imagined. Further support for multiverse theories emerges from the realm of quantum mechanics, where the behavior of particles at the smallest scales hints at a multiplicity of outcomes coexisting simultaneously. The many worlds interpretation, for example, proposes that every quantum event spawns a branching of universes, each representing a different possible outcome. While this idea remains theoretical, it aligns intriguingly with observed phenomena and mathematical frameworks that describe the quantum world. Experimental tests continue to probe the boundaries of this interpretation, seeking subtle signatures that might reveal the presence of these parallel realities. This ongoing research reflects a profound shift in our understanding, one that blends the abstract elegance of mathematics with the tangible quest for empirical evidence. It invites us to contemplate a cosmos where probability and possibility are woven into an endless tapestry of alternate dimensions. In addition to cosmic and quantum insights, string theory offers another avenue through which multiverse concepts gain scientific traction. This theoretical framework, which attempts to unify all fundamental forces and particles, predicts the existence of additional spatial dimensions beyond the familiar three. These extra dimensions could harbor entire universes, layered or folded in ways that evade our direct perception. While these dimensions remain hidden from everyday experience, their mathematical necessity provides a compelling argument for the existence of alternate realms. Researchers continue to investigate how these extra dimensions might influence observable phenomena, such as particle physics experiments and gravitational waves. Each step forward in this domain enriches our understanding of the cosmos, suggesting that the multiverse may be deeply embedded in the very structure of reality itself. Observational cosmology also contributes to the discourse by examining large-scale structures and the distribution of matter in the universe. Certain patterns, like the cold spot in the cosmic microwave background or the unexpected alignment of galaxy clusters, have prompted scientists to consider whether these could be the fingerprints of interactions with other universes. Though such interpretations are tentative, the pursuit of these anomalies exemplifies the patient, meticulous nature of scientific inquiry. It encourages an openness to possibilities that extend beyond conventional cosmological models, fostering a dialogue between theory and observation. As technology advances and data accumulates, these subtle hints may evolve into clearer signals, bringing us closer to understanding how our universe fits within a grander, multiversal ensemble. The intersection of these diverse lines of research paints a picture of a cosmos rich with hidden layers and profound mysteries. Each scientific discovery, whether it arises from the faint whispers of ancient light, the peculiarities of quantum particles, or the mathematical elegance of higher dimensions, adds a thread to the intricate fabric of multiverse theories. These threads encourage us to continually expand our perspective, embracing the vastness of possibility that lies beyond the boundaries of our observable universe. As we gently move forward, this growing body of evidence invites us to consider how these alternate realities might influence our quest for knowledge, inspiring new questions and deeper reflections about the nature of existence itself. As we contemplate the vastness of the cosmos, the idea of dimensions beyond the familiar three of space and one of time emerges as a captivating possibility. These extra spatial dimensions are not merely abstract concepts, but play a crucial role in modern theoretical physics, particularly within the framework of string theory. Unlike the tangible dimensions we navigate daily, these additional dimensions are thought to be compactified or curled up at scales so minuscule that they elude direct observation. This subtlety allows them to remain hidden, yet their presence profoundly influences the fundamental forces and particles that constitute our universe. String theory suggests that the vibrations of tiny, one-dimensional strings within these higher dimensions give rise to the variety of particles and forces we observe, weaving a delicate interplay between geometry and physics. In this light, alternate dimensions offer a richer tapestry of reality, inviting us to refine our understanding of space itself and challenging the limits of our perception. The concept of extra dimensions naturally extends to the broader idea of parallel universes, where each alternate dimension might host a distinct version of reality. These parallel universes, sometimes described as brain worlds in string theory, suggest that our four-dimensional universe could be one among many, each existing on a higher dimensional membrane, floating within a grander cosmic structure. Such a framework provides fertile ground for multiverse theories, where the diversity of physical laws and constants across these universes could explain why our own cosmos appears finely tuned for life. The interactions, or sometimes isolation, between these brains could determine how separate or connected these universes truly are, hinting at phenomena that remain beyond our current experimental reach. This perspective not only expands the scope of cosmic inquiry, but also invites philosophical reflections on the nature of reality and our place within this vast ensemble of possibilities. Beyond the mathematical elegance of string theory, alternate dimensions also resonate with other scientific ideas, exploring the fabric of the cosmos. Concepts like the holographic principle and higher dimensional black holes reveal how information and physical processes might manifest differently when viewed through the lens of extra dimensions. In some models, alternate dimensions could influence gravitational behavior or even the formation of cosmic structures, offering explanations for phenomena that challenge conventional understanding. While direct empirical evidence remains elusive, the pursuit of these ideas drives advances in both theoretical and experimental physics, encouraging innovative approaches to detect subtle signatures of higher dimensional effects. Through this ongoing exploration, the notion of alternate dimensions becomes more than a theoretical curiosity. It evolves into a vital component of our quest to unify the forces of nature and unlock the deeper secrets of the universe. As we continue to navigate these intricate theories, the interplay between alternate dimensions and the multiverse concept underscores a profound shift in how we conceptualize existence. Rather than viewing our universe as a singular, isolated entity, these ideas open the door to a multitude of realities, each shaped by different dimensional frameworks and physical laws. This expansive vision challenges traditional notions of space and time, prompting us to reconsider the boundaries of scientific exploration and human imagination. It is within this rich context that we begin to appreciate the subtle dance of dimensions and universes, inviting us to explore further the mysteries that lie beyond the horizon of our current understanding. At the heart of many modern explorations into the nature of reality lies string theory, a framework that seeks to unify the fundamental forces of physics by proposing that the basic constituents of the universe are not point-like particles, but rather tiny, vibrating strings. These minuscule strands oscillate at different frequencies, giving rise to the diverse particles and forces we observe. Yet, what makes string theory especially intriguing in the context of multiverse speculation is its requirement for additional spatial dimensions beyond the familiar three of everyday experience. According to the mathematics of the theory, the universe is woven from 10 or even 11 dimensions, most of which remain hidden from direct observation because they are compactified or curled up at scales far smaller than an atom. This elegant structure offers a glimpse into a reality far richer and more complex than our senses suggest, opening the door to the possibility that these extra dimensions might serve as gateways or scaffolds for other universes or realms beyond our own. These extra dimensions in string theory do not merely act as abstract mathematical necessities. They provide a fertile ground for imagining how multiple universes could coexist with different properties and physical laws. In some versions of the theory, each possible way these dimensions can be compactified corresponds to a unique universe with its own distinct set of constants, particles, and forces. This landscape of potential universes, sometimes called the string landscape, suggests that what we perceive as the fine-tuned conditions of our own cosmos might be one of countless variations scattered across a vast multiverse. These alternative realities could be as different from ours as a sphere is from a cube, or as a world ruled by entirely different physical rules. Such a perspective challenges our traditional understanding of uniqueness and inevitability in the cosmos, inviting us to consider that our universe may be but one thread in a far grander cosmic tapestry. The concept of extra dimensions also provides intriguing connections to the idea of parallel universes. While popular culture often imagines parallel worlds existing side by side, string theory offers a scientific framework in which these realities could be layered within dimensions beyond our perception. These hidden dimensions might host entire universes, their presence subtly influencing the physics we observe. Or perhaps existing entirely separate from our own space-time. In this light, the multiverse is not simply a distant abstraction, but an intrinsic part of the fabric of existence, woven through the extra dimensions that underlie all phenomena. The challenge of detecting or interacting with these dimensions remains immense, but the very possibility enriches our quest to understand the cosmos and our place within it. Through the lens of string theory, the boundaries of our universe become fluid, and the idea of a singular, isolated cosmos gives way to a vision of countless realms interconnected by the subtle geometry of extra dimensions. This theoretical vista intertwines the language of physics with the imagination of metaphysics, suggesting that the universe we inhabit is but one expression of a deeper, multi-dimensional reality. As we continue to refine our understanding and develop new tools to probe these hidden dimensions, we edge closer to unraveling the mysteries that have captivated human inquiry for centuries. It is within this unfolding narrative that the dialogue between string theory, extra dimensions, and the multiverse deepens, inviting us to ponder the vastness that lies just beyond the veil of our current perception. Within the evolving landscape of theoretical physics, the concept of brain worlds emerges as a fascinating extension of multiverse ideas. According to brain theory, our familiar universe might be thought of as a three-dimensional membrane, or brain, floating within a higher dimensional space. These brains are not isolated entities, but can exist alongside other brains, each potentially harboring its own universe with distinct physical laws and constants. This perspective enriches the multiverse narrative by suggesting that our cosmos is one of many membranes, each gently undulating in the fabric of a more expansive reality. The idea invites us to imagine that what we perceive as empty space might actually be a vast, multi-dimensional arena where countless universes coexist, separated not by conventional distances but by the geometry of higher dimensions. The mathematical framework behind brain theory arises from string theory and E-theory, where fundamental particles are conceived as tiny vibrating strings attached to these membranes. In this setting, the extra dimensions required by string theory are not merely abstract mathematical constructs, but provide the stage upon which entire universes are arranged. Our own universe, in this brain world scenario, could be constrained to a three-dimensional slice of a higher dimensional bulk, influencing how gravity and other fundamental forces behave. This offers intriguing explanations for why gravity appears weaker compared to other forces. It might be that gravitational effects leak into or originate from the surrounding bulk, diluting their strength within our brain. Such insights deepen our appreciation of the universe's architecture, suggesting that the physical laws we observe may be local properties of our particular membrane, distinct from those governing neighboring brains. The concept of brain worlds also provides fertile ground for exploring interactions between universes. Some models propose that brains might occasionally collide or influence each other through subtle exchanges across the higher dimensional space they inhabit. These interactions could manifest as cosmic phenomena observable within our universe, potentially offering clues to the nature of the multiverse. For example, a collision between brains might be interpreted as a Big Bang event, initiating the birth of a universe like our own. Such possibilities shift the multiverse from an abstract hypothesis to a framework with potential empirical touchpoints, even if they remain challenging to detect. This dynamic landscape of membranes introduces a profound reimagining of existence itself, where the boundaries of a universe are not fixed, but part of a larger, interconnected, multi-dimensional mosaic. As we consider the implications of brain theory, we also encounter the notion that alternate dimensions may host entirely different forms of matter and energy, shaped by the unique conditions of their respective membranes. This expands the scope of parallel universes beyond mere copies or variations of our own cosmos, suggesting a diverse ensemble of realities with potentially unfamiliar physics and geometry. The brain world idea thus bridges the gap between the abstract mathematics of higher dimensions and the tangible quest to understand our universe's origin and structure. It encourages a view of reality as a layered expanse where the familiar and the unknown coexist, separated by dimensions we have yet to fully explore. This perspective invites a patient, open-minded inquiry into the nature of existence, challenging us to look beyond the visible horizon. In this evolving dialogue between theory and imagination, brain worlds offer a compelling lens through which to view the multiverse. They prompt us to consider that our universe's apparent uniqueness might be a consequence of its position and properties as a membrane within a grander spatial framework. Each brain, each universe, becomes a distinct note in an intricate cosmic symphony, resonating within the higher dimensions. As research advances and our tools become more refined, the possibility grows that we may detect subtle echoes or signatures of these other membranes, glimpsing the broader reality in which our own universe is embedded. This ongoing exploration guides us gently toward the next chapter of understanding, where the ideas of parallel universes and alternate dimensions weave ever more closely together. When we contemplate the existence of parallel universes, we are invited to reevaluate the very fabric of reality itself. The concept that countless versions of existence might unfold simultaneously challenges the traditional notion that there is only one definitive timeline or outcome for any event. Instead, reality could be viewed as a vast, branching network of possibilities, each universe representing a different path taken or a different choice realized. This plurality of realities gently unsettles our perception of certainty, encouraging us to embrace a more fluid and expansive understanding of what is real. It is a humbling reminder that our experience, though vivid and immediate, may be but one thread within an immense cosmic tapestry. Beyond the question of reality lies the profound inquiry into identity. If parallel universes contain alternate versions of ourselves, each shaped by different circumstances and decisions, then what truly defines us? Are we singular beings, unique and unchanging? Or do we exist as a collection of selves, spread across multiple planes of existence? This perspective invites a serene reflection on the nature of selfhood, suggesting that identity might be more fluid, less fixed than we imagine. It implies that our sense of individuality could be part of a broader, interconnected pattern where each variant self is both distinct and intimately connected to the others. Such an idea does not diminish our uniqueness, but rather expands it, allowing space for the coexistence of multiple possibilities within the concept of who we are. Perhaps most intriguingly, the existence of parallel universes calls into question the concept of free will. If every choice we make spawns a new reality where an alternate decision is realized, then the traditional view of free will as the power to choose one path over another becomes more complex. Instead, free will might be understood as the ability to navigate among an infinite array of potential outcomes, each manifested in a different universe. This notion neither confines us to a predetermined destiny, nor grants absolute control, but rather situates our experience within a vast cosmic dance of possibilities. Contemplating free will in this light encourages a gentle acceptance of uncertainty and an appreciation for the delicate interplay between choice, chance, and consequence. As we immerse ourselves in the implications of parallel universes and alternate dimensions, it becomes clear that these ideas extend beyond abstract theory into the realm of philosophical and existential reflection. They subtly shift the lens through which we view our place in the cosmos, suggesting that reality is not a singular, static entity, but a dynamic and multifaceted phenomenon. This evolving perspective invites a sense of wonder and humility, reminding us that, despite our limited experience, the universe may be infinitely richer and more intricate than we can presently comprehend. With each new insight, the boundaries between what is known and what is possible gently blur, guiding us toward deeper questions and ever more expansive horizons. As the concept of the multiverse has gained traction within scientific circles, it has also found a fertile ground in popular culture. Movies, books, and games have embraced the idea of parallel universes and alternate dimensions, weaving them into narratives that captivate audiences worldwide. These creative interpretations offer accessible gateways to complex scientific theories, rendering abstract ideas into vivid experiences. Through stories of characters encountering alternate versions of themselves or traveling between diverse realities, the public is invited to contemplate not only the mysteries of space and time, but also the nature of identity and choice. This interplay between science and storytelling enriches our collective imagination, allowing us to explore profound questions in ways that resonate emotionally and intellectually. In literature, the multiverse often serves as a canvas for thought experiments, where authors envision worlds shaped by different histories, physical laws, or outcomes of pivotal events. Such explorations challenge readers to consider the delicate balance of factors, that shape existence as we know it. Meanwhile, film and television bring these ideas to life through stunning visuals and compelling narratives, often blending scientific speculation with myth and philosophy. Video games, with their interactive nature, allow players to traverse multiple dimensions firsthand, making the experience intensely personal and immersive. This widespread engagement helps demystify scientific concepts, fostering curiosity and encouraging deeper inquiry. It also reflects a cultural fascination with the unknown, as people seek to understand their place within a potentially infinite cosmos. The appeal of parallel universes in popular culture extends beyond mere entertainment. It taps into fundamental human desires to explore possibilities beyond the constraints of our lived experience. The notion that countless realities might exist alongside our own offers a sense of wonder and hope, suggesting that different paths and outcomes are always within reach, at least in theory. This can inspire reflection on the choices we make and the nature of destiny itself. Moreover, the multiverse serves as a metaphor for diversity and complexity, reminding us that reality is layered and multifaceted. In this way, popular culture both mirrors and shapes our understanding of scientific ideas, creating a dynamic dialogue between imagination and knowledge. As these stories continue to evolve, they often incorporate the latest scientific discoveries and hypotheses, enriching the narrative fabric with authentic elements of physics and cosmology. This blending of fact and fiction not only entertains but also educates, sparking interest in scientific fields such as quantum mechanics, string theory, and cosmology. As audiences engage with these themes, they become participants in a broader cultural conversation about the nature of reality itself. This ongoing exchange highlights the power of storytelling to extend the reach of scientific thought beyond academic circles, making complex ideas more approachable and meaningful. In doing so, popular culture acts as a bridge, connecting the mysteries of the multiverse with the human experience of wonder and curiosity. The concept of a multiverse, while captivating and rich with imaginative potential, presents formidable challenges when approached from a scientific perspective. Unlike phenomena that can be directly observed or measured, the idea of parallel universes or alternate dimensions often lies beyond the reach of our current empirical tools. The very nature of these theories suggests the existence of realms that are causally disconnected from our own, making direct observation merely impossible. This fundamental limitation places the multiverse firmly at the frontier of physics, where speculation and rigorous science intersect in a delicate balance. Efforts to test multiverse hypotheses frequently rely on indirect evidence or mathematical consistency within existing theoretical frameworks, rather than straightforward experimental validation. One of the primary difficulties in proving the multiverse stems from the constraints of observational cosmology. Our instruments, no matter how advanced, are confined to detecting signals within our observable universe. If other universes exist, they may be separated by vast expanses of space and time, or even reside in entirely different dimensions, making any interaction or exchange of information fundamentally prohibited. Some approaches suggest looking for subtle imprints in the cosmic microwave background radiation, faint echoes of collisions between our universe and neighboring ones, but such signatures remain speculative and open to alternative explanations. Consequently, the challenge is not only technical but also conceptual, as scientists must devise clever, indirect methods to gather clues about these elusive realms. Theoretical physics offers various models that imply the existence of multiple universes, such as the inflationary multiverse, the many worlds interpretation of quantum mechanics, and the complex landscape of string theory. Each of these frameworks extends our understanding of reality, but simultaneously introduces new puzzles. For example, the many worlds interpretation proposes that every quantum event branches into separate, coexisting realities, all equally real yet inaccessible to one another. While mathematically elegant, this idea challenges traditional notions of testability and falsifiability, cornerstones of the scientific method. Similarly, string theory's suggestion of extra-spatial dimensions and a vast landscape of possible vacuum states hints at a multiverse, but the theory itself remains unproven, partly because it requires energies far beyond current experimental capabilities. These theoretical frontiers highlight the delicate interplay between imagination and evidence, inviting us to rethink what it means to explore the cosmos. Despite these hurdles, the pursuit of understanding the multiverse continues to inspire innovation in both experimental techniques and philosophical inquiry. Scientists are exploring novel observational strategies, such as searching for gravitational waves or subtle anomalies in particle physics experiments, that might indirectly support multiverse scenarios. At the same time, the philosophical implications touching on the nature of existence, causality, and the limits of human knowledge invite a broader dialogue that extends beyond the laboratory. This ongoing quest exemplifies the spirit of scientific exploration, embracing uncertainty and expanding the boundaries of what we consider knowable. It is a reminder that, even when direct proof remains out of reach, the journey itself enriches our appreciation of the universe's profound mysteries. As these scientific and philosophical efforts advance, they open pathways to new questions and possibilities, encouraging us to remain curious and open-minded. The challenges of proving the multiverse underscore the delicate balance between what can be measured and what must be inferred, between the tangible and the theoretical. This delicate balance invites continued reflection on the nature of reality, encouraging deeper contemplation as we venture further into the unknown. In recent years, the pursuit of understanding the multiverse has gained remarkable momentum, driven by advancements in both observational technology and theoretical physics. Among the most significant contributors to this progress is the European Space Agency's Planck satellite, which has provided some of the most detailed measurements of the cosmic microwave background radiation, the faint afterglow of the Big Bang. Subtle anomalies in this ancient light have intrigued scientists, as they may hint at interactions or influences beyond our observable universe. These patterns, while subtle and open to interpretation, offer a tantalizing glimpse into the possibility that our universe might be just one of many, a member of a vast cosmic ensemble. Such data challenges us to rethink our place in the cosmos and to consider what signatures might betray the presence of parallel universes or alternate dimensions. The Planck satellite's findings have thus become a cornerstone for new hypotheses, fueling the imagination of physicists and cosmologists alike as they seek to decode the language of the universe on the grandest scale. The theoretical frameworks supporting multiverse ideas have also evolved in tandem with observational breakthroughs. Concepts such as eternal inflation suggest that our own universe is but one bubble in a frothy sea of expanding space-time regions, each potentially governed by different physical laws and constants. This motion introduces the idea of a cosmic landscape, a vast terrain of possible universes where the conditions for life and matter might vary dramatically. Meanwhile, string theory and its extension into M-theory propose the existence of multiple dimensions beyond the familiar 3 of space and 1 of time. These extra dimensions, compactified or curled up at scales beyond direct detection, might harbor alternate realities that coexist alongside our own. Together, these theories form a complex tapestry that blurs the line between science and philosophy, inviting us to expand our understanding of what constitutes reality itself. Experimental efforts continue to explore these ideas by searching for indirect evidence of multiverse interactions. For instance, some researchers investigate whether collisions between our universe and others could leave imprints in cosmic radiation or gravitational waves. Others look for subtle variations in fundamental constants or quantum fluctuations that might indicate influences from alternate dimensions. While direct observation remains elusive, these approaches underscore a growing sophistication in how scientists probe the boundaries of knowledge. They remind us that the quest to uncover the multiverse is not merely a speculative endeavor, but one grounded in rigorous empirical inquiry. Each new study deepens the mystery, encouraging patient and open-minded exploration as we inch closer to understanding the profound architecture of reality. As the tools of science become ever more refined, the dialogue between theory and observation grows richer, revealing a cosmos far more intricate than once imagined. The potential existence of parallel universes and alternate dimensions invites a humbling perspective, one where our familiar world is but a single thread woven into a vast and complex cosmic fabric. This expanding horizon challenges us to cultivate patience and wonder, recognizing that the ultimate answers may lie beyond the limits of current technology and understanding. Yet it is precisely this horizon that propels ongoing research, and inspires a new generation of thinkers to continue exploring the profound question of what lies beyond our observable reality. With each discovery, the boundaries of the known universe gently recede, allowing us to peer deeper into the mysteries that await. The contemplation of multiverse theories gently nudges us toward profound philosophical inquiry, inviting reflection on the nature of existence itself. If countless parallel universes unfold alongside our own, each hosting variations of reality, the question arises, what does it mean to be unique? Our sense of self, so deeply rooted in the singularity of experience, encounters a subtle challenge. Could there be other versions of ourselves, living out alternative choices and paths? This notion encourages us to reconsider the concepts of identity and individuality, prompting a quiet meditation on what truly defines our being. In this vast cosmic ensemble, the familiar boundaries between self and other, here and there, now and then, begin to blur, opening a contemplative space where philosophy and cosmology intertwine. Here, the multiverse becomes more than a scientific idea. It becomes a mirror, reflecting the deepest questions about consciousness, existence, and the intertwined nature of reality. Beyond the personal and philosophical, multiverse theories also usher in ethical considerations that ripple through our understanding of responsibility and choice. If infinite versions of events unfold across countless dimensions, does this dilute the significance of our actions? Or does it, perhaps, deepen our appreciation for the singular moment we inhabit? The ethical landscape becomes richer and more complex, encouraging us to reflect on the weight of decisions within our own universe, even as countless alternatives play out elsewhere. This perspective invites humility, recognizing that while science may illuminate vast scales of reality, it also reminds us of the fragile preciousness of life and the moral fabric we weave through our choices. In this light, the multiverse does not diminish human meaning, but instead underscores the profound interconnectedness and the enduring importance of ethical reflection in an ever-expanding cosmic context. The exploration of alternate dimensions and parallel universes also challenges traditional philosophical frameworks about causality and determinism. If multiple realities exist simultaneously, each branching from different choices or initial conditions, the linear narrative of cause and effect becomes a more intricate tapestry. This invites us to embrace complexity and uncertainty, fostering an openness to the mystery and unpredictability woven into the fabric of existence. Such a perspective encourages a gentle acceptance of ambiguity and paradox, reminding us that the universe, and perhaps the multiverse, is not bound by simple rules or singular truths. Instead, it may be a boundless realm of possibility, inviting continual inquiry and wonder. This philosophical openness enriches our engagement with science, encouraging a dialogue where questions often matter as much as answers. Moreover, the idea of parallel universes gently invites reconsideration of human meaning and purpose within a broader cosmic panorama. If myriad worlds exist beyond our perception, each with its own unfolding narrative, the search for significance may shift from seeking an absolute center to embracing a more expansive view of existence. This perspective fosters a sense of humility and awe, acknowledging that our story is part of a vast and intricate multiversal symphony. It encourages us to find meaning not only in grand cosmic terms, but also in the quiet moments of connection, curiosity, and creativity that shape our lives here and now. In this way, multiverse theories inspire a contemplative balance between the vast unknown and the intimate present, inviting us to engage with both the mysteries beyond and the realities within. The notion of visiting parallel universes, once confined to the realm of imaginative fiction, now finds tentative footing in the speculative edges of scientific inquiry. Theoretical models in physics, such as the many worlds interpretation of quantum mechanics or the concept of brain cosmology, suggest that our universe could be just one of countless others, each inhabiting its own distinct reality or dimension. While these ideas remain deeply theoretical, they inspire profound questions about whether it might one day be possible to traverse or communicate across these boundaries. Could advanced technologies, yet to be conceived, enable us to detect subtle signs of neighboring universes, or even create bridges between them? Such possibilities ignite a serene curiosity, encouraging us to imagine a future where exploration extends beyond the familiar fabric of space-time to encompass the vast tapestry of multiversal existence. Scientific efforts to probe the nature of parallel universes often orbit around the search for indirect evidence. For instance, cosmologists examine the cosmic microwave background radiation, the afterglow of the Big Bang, for anomalies that might hint at collisions or interactions with other universes. Similarly, quantum experiments continue to challenge our understanding of reality's underlying structure, revealing phenomena that could be interpreted as glimpses into alternate branches of possibility. While these approaches are subtle and require extraordinary precision, they gently illuminate the edges of our knowledge, inviting us to expand the scope of what is empirically accessible. The dream of crossing into an alternate dimension remains distant, but the pursuit itself enriches our sense of wonder and expands the horizons of human inquiry. The exploration of alternate dimensions also raises fascinating questions about the nature of consciousness and perception. If multiple versions of ourselves exist across different realities, how might awareness function in such a context? Some speculative theories propose that consciousness could be a bridge between parallel worlds, or that advanced forms of technology might one day allow us to experience the lives of our counterparts in alternate universes. This delicate interplay between physics and philosophy encourages a contemplative openness, where the boundaries between science, imagination, and spirituality softly blur. Imagining journeys through parallel universes invites us to reconsider the very fabric of identity, presence, and existence, enriching our understanding of what it means to be alive within this vast and mysterious multiverse. From a practical standpoint, however, the challenges to visiting or interacting with parallel universes remain immense. The energy scales, dimensional barriers, and fundamental laws that might separate these realms are far beyond current technological reach. Yet, the history of science reminds us that what is impossible today may become feasible tomorrow through new insights, discoveries, and innovations. The gentle unfolding of scientific progress often begins with bold speculation, nurtured by curiosity and a patient willingness to explore the unknown. In this spirit, the quest to understand and perhaps someday connect with alternate realities continues to inspire generations of thinkers, inviting us to dream beyond the limits of our present experience. As we contemplate the vast possibilities suggested by multiverse theories, it is natural to feel a profound sense of wonder at the sheer scale and complexity of reality. The idea that our universe might be just one of countless others, each with its own unique properties and histories, challenges our traditional notions of existence. These parallel universes and alternate dimensions invite us to expand our understanding beyond the familiar confines of space and time. While the scientific community continues to explore these concepts with rigor and caution, the implications remain deeply inspiring. They encourage us to consider not only the physical cosmos, but also the philosophical questions about our place within such a grand and possibly infinite tapestry. In embracing this broader perspective, we find a humbling yet exhilarating reminder that our journey of discovery is far from complete, and that the mysteries of the multiverse offer endless opportunities for new insights and wonder. The exploration of multiverse theories also highlights the delicate balance between imagination and empirical science. Though many ideas about parallel universes stem from mathematical models and theoretical physics, their potential existence invites us to reflect on the limits of human knowledge. Each new hypothesis pushes the boundaries of what we consider possible, urging us to refine our instruments, expand our methods, and deepen our curiosity. This interplay between the known and the unknown is the heart of scientific endeavor. It reminds us that the cosmos is not a static backdrop, but a dynamic and evolving arena filled with surprises waiting to be uncovered. In this way, the multiverse becomes a symbol not only of vastness, but also of the enduring human spirit that seeks to understand its place amidst the infinite. Furthermore, the concept of alternate dimensions and parallel realities invites us to reflect on the nature of existence itself. If multiple versions of reality coexist, then the uniqueness of our own experience becomes both precious and deeply connected to a wider cosmic narrative. This perspective encourages compassion and humility as we recognize that our story is but one thread in an immense cosmic fabric. It also sparks creative thought about the possibilities of life, consciousness, and reality beyond our immediate perception. Though speculative, these ideas inspire us to look upward and inward simultaneously, nurturing a sense of awe and gratitude for the mystery that envelops us all. Such reflections remind us that science and imagination are partners in the timeless quest to comprehend the universe and our place within its boundless expanse. Ultimately, the study of multiverse theories and alternate dimensions invites us to embrace curiosity as a guiding light. Even if direct evidence of parallel universes remains elusive, the pursuit itself enriches our understanding of nature and highlights the beauty of scientific inquiry. In contemplating the multiverse, we are encouraged to remain open to new possibilities and to cherish the unknown as a source of inspiration rather than fear. This mindset fosters a deeper connection with the cosmos, inviting us to participate in an ongoing dialogue that transcends time and space. As we continue to explore these profound questions, we carry forward a legacy of wonder, creativity, and hope that will illuminate the path for generations to come. In closing, the multiverse theories remind us that the universe is far more intricate and mysterious than we can presently grasp. Our place within this vast ensemble may be small, but it is significant, an invitation to reflect, to dream, and to explore. The possibility of parallel worlds and alternate dimensions enriches our appreciation for the cosmos and ignites an enduring curiosity that propels us forward. As we gaze into the depths of space and the fabric of reality, let us carry with us a sense of awe and a quiet reverence for the unknown. For within this vast cosmic expanse, we find not only answers, but also the inspiration to keep seeking, learning, and imagining. The multiverse is not merely a scientific theory. It is a profound reminder of the beauty and mystery that surround us all.